Tylko, że... Dobra, to chodzi.
A zajął jakieś miejsca? To jeszcze się wsadzi. Dobra.
Alright, hello everyone. First, air conditioning is working. However, they turned it off like an hour ago and it's supposed to take 2 hours to make it fully functional. So, be patient. Hopefully. Alright, 38 Java Wrocław Java user group meeting. When I say Java tonight, it's not exactly true. I know there are people from .NET user group, there are people from Ruby, there are people from Python. We even have QA engineers from Wrocław. Oh, And do you know why we are all here? We are all here because of my best friend. And my best friend, a few weeks ago, had a wedding. And I was at the wedding, and I was sitting at a bar with one of our friends. I wasn't sober, and neither was he. And he was like, you know what? You should invite Uncle Bob. And I was like, I will! I will! Next day, I wrote an email, and I said, well, would it be possible? Blah, blah, blah. And after like 12 hours, Uncle Bob like, yeah. So it was getting surrealistic every single hour. And that's why we are all here today. So, without further ado, please welcome Uncle Bob.
Hello.
Can you hear me? Yeah. All right, in the back. Way back there. Can you hear me?
Yes.
Yeah? Yeah. So I don't need this. Best hour. I turned it off. If I need the microphone, let me know. I'm going to use this loud voice of mine, and we'll see how well that works, because I hate microphones. In the back okay? Yeah. Yeah, somebody's got a video camera. Are you getting enough audio? Or is it heavy with reverb? Well, you were going to get that anyway, weren't you? All right. Everybody get their picture taken? Book signed. Thank you all very much. I'm done now. So the name of my talk is Architecture, the Lost Years. This is a talk that I have given many, many times to many groups. This may be the largest that I've given it to. Thank you all for attending. That's kind of exciting for me. I have never, ever seen my presentation on a movie screen before. That's a new experience for me. Well, my presentation is a movie star. I'm not on it. So, how big is the galaxy? Ooh, very good. 100,000 light years, 120,000 light years. Right about that area. We should know these things. We live here. How do we know that the galaxy is about 120,000 light years in diameter? How do we know that? We measured it. Someone said. We estimate. Well, there's a lot of estimation involved. Let me tell you the story. The story is fascinating. Right around 1901, there was a woman by the name of Henrietta Leavitt. Henrietta Leavitt was studying a certain kind of star. These stars are called variable stars because they change their brightness from night to night. And they change their brightness with a very strict pattern. They will get dimmer and dimmer and dimmer and then suddenly bright, and then dimmer and dimmer and dimmer and suddenly bright. A variable star of this kind is very accurate. It will change its brightness maybe once every 5 days, maybe once every 10 days. Every variable star is different, but if it has a period of 5 days, it will oscillate very predictably every 5 days. If it's 10 days, it will be very predictably 10 days. following the same light curve over and over and over again. Henrietta Leavitt was studying these stars, but she did something smart. She studied them inside of another object. That object is called a globular cluster. Has anybody seen a globular cluster in a telescope? Nobody has seen a oh, you have, way in the back there with the camera. A globular cluster is a sphere of stars, perhaps 1 light year in diameter. And inside that light year there are 100,000 stars. They are jewels. They're the most beautiful things you can see in a telescope. They're dense in the middle and they get thinner and thinner and thinner as you get to the outside. There are about 250 of them that you can find in the nighttime sky, depending on whether it's summer or winter. You go outside where it's dark, you find some telescope that can show you a globular cluster. You point your telescope at the globular cluster and just stare at it. It's gorgeous. The interesting thing about the stars in a globular cluster is that they're all the same distance from us. So if you can find 3 or 4 variable stars in there, you can subtract distance out as a variable. And this is what Henrietta Leavitt did. She found several variable stars in one particular globular cluster, and she knew they were all the same distance from us. So she was able to measure the period, the amount of time it took to go through its cycle, and compare it against their brightness. And what she found was that the brighter the star, average brightness, the brighter the average brightness, the slower the star would oscillate. And this was so predictable, she came up with a formula that would describe, if you knew the brightness, the formula would tell you the period. If you knew the period, the formula would tell you the brightness. Someone else measured the distance to a variable star through a different means. And by doing that, they were able to add another variable to Henrietta Leavitt's equation. Now it was brightness, period, and distance. You know any two, you can get the third. You look at a variable star out there, you see its brightness, you see its period, now you know how far away it is. And so we took this formula and we measured the distance to every globular cluster in the sky. And what we found was that all these globular clusters form a sphere. The center of that sphere is 30,000 light years away in the constellation of Sagittarius. That must be the center of the galaxy. All the globular clusters are probably gravitationally bound to the center of the galaxy. That's 30,000 light years away. If we turn around and look in the direction opposite of Sagittarius, we still see that band of the Milky Way, so we assume there's another 30,000 light years of galaxy in that direction. The radius is 60,000, the diameter is 120,000. That's how we know how big the galaxy is. And that's not what we're supposed to be talking about. Architecture. It was about 4 years ago that my son showed me some code. And in that code, he gave it to me in a directory, and the directory looked like this. Now, I recognized it. I recognized this as a Rails application. Anybody here done any Ruby on Rails? Oh, look at that. Yes. Oh, lots of folks have. In the United States, if you are a Ruby programmer, you can write a number on a piece of paper and find someone to pay you that number. Right? Because Ruby programmers are in very hot demand in the United States. All the social networking companies want to have Ruby programmers. That may not be true in Poland, but it's true in the US. I recognized this as a Rails application. You can tell it's Rails because it's got the app folder, it's got a controllers folder, and a models folder, and a view folder, and a util folder, and a whole bunch of reasons why I recognized that this was a Rails application. And that bothered me. Why is it that I could look at the top level directory of this application and identify the framework it uses and not know what the application does? Why is the framework so important that it screams out its identity at the very top level of the application, and yet the purpose of the application remains hidden? Something's wrong with that. And it made me think. Rails is a web framework. And the web is a detail. The web is not architecturally significant. This took us a long time to rediscover. When the web first started in the late 90s, we all thought, whoa, this is changing everything. But it didn't change anything. Because the web is just an I/O channel. It's an input and an output device, like any other input or output device. It shouldn't change anything architecturally. And yet it became the core of that structure. The web is a delivery mechanism, an I/O channel. How did it get to be so preeminent? How did it get to influence the architecture so strongly? So I started looking at architecture diagrams of buildings. And I noticed something. If you look at the blueprint of a building, the architecture of a building, what you see is the purpose of the building. That's a library. It's obviously a library. It says library. But even if it didn't say library, you could look at it and see, oh, look, there's bookshelves, there's reading tables, there's some computer tables, which all libraries have to have now. There's this area over here called circulation. This is obviously a library. And if that didn't convince you, this one will. That's a church. It's obviously a church. And this made a point to me. The architecture of a building screams, thank you, for what? The architecture of a building screams out its intent. You look at the picture of this building and you understand its intent. Architecture is about intent. Am I reaching the guys in back?
Yeah.
Yeah? Do I need that microphone?
No.
No. I won't ask again. Architecture is about intent. That means that the architecture of your application should scream out the intent of the application. Someone should be able to look at the top level of your application and say, oh, that's an accounting application. That's a payroll application. That's a phone application. They should be able to look at it and see what it is, just like you can look at that church and know that it is a church. And that made me remember this guy. Who knows who that is? It is. It's Ivar Jakobsen. In 1992, Ivar Jakobsen wrote this book, Object-Oriented Software Engineering, a Use Case-Driven Approach. I can't tell you how excited we were when we knew this book was coming. And we all waited for it to come out. And when it was published, we all went out and bought it, and we read it, and it was very exciting. Does anybody remember use cases? Oh, look, a few of you do. All right, and how many of you remember them as a nightmare? Okay, about half of the people who raised their hands before. What happened, and this happens to all of software, and it always happens, is that every good idea gets perverted. Every good idea gets stolen by consultants like me who then screw it up for everybody else. In the case of use cases, what happened was that a whole bunch of consultants needed to capitalize on the idea of use cases, and so they started publishing use case forms. And when you publish a use case form, you've got to put blanks or fields in that form. So they had to invent things to put in those forms. And they invented things like primary actors and secondary actors and tertiary actors and preconditions and postconditions and goal statements and all this stuff that you had to fill out on the form. And of course that made everybody go, well, this is too much stuff and we don't want to do it, and the whole thing died. Let me show you what Jacobson would have made of a use case. That is a Jacobsonian use case. It has very little structure to it. It's got a name, create order. Imagine this is for an order entry system. It's got some data. Notice that I don't specify anything about the structure of that data. All I say is, as customer ID, I don't tell you what that customer ID is. I don't tell you it's a string or an integer. No clue. Got shipment destination. I tell you nothing about the shipment destination. It's not the business of the use case. Payment information, customer contact information, shipment mechanism. I name them, I don't define them. That's typical of a use case. A use case does not have detail in it. Having defined all of the input, I walk through the basic processing steps. The order clerk issues the create order command with the above data. That's not even part of the use case. That comes before the use case begins. The system will validate all the data. How? I don't bother to specify. Just going to validate all this stuff, whatever that stuff is. System creates the order and determines the order ID. I presume that must be a database operation, but I'm not going to say that here. And finally, system delivers the order ID to the clerk, probably on a web page. I don't know, maybe, but I'm not going to say how. Jacobson made the point that you can take that and turn it into an object. The object, which I call an interactor, which Jacobson called a control object. I changed it to interactor because I didn't want confusion with model view controller. An interactor embodies a use case. It's got a function inside of it. That function takes the input data of the use case and somehow produces the output data of the use case. Not a lot of rocket science there. How does that happen? Well, notice the words here. Interactors have application-specific business rules. Application-specific business rules. Not all business rules are application-specific. Some business rules can be used in multiple applications. But some business rules can only be used in one application. Those are application-specific. The interactor encodes for all of the application-specific business rules. The application-independent business rules, the one that could be used in many applications, are encoded into entities. Jacobson called these things entities. Nowadays we call them business objects. An entity is a business-related object that has methods on it that could be used in multiple applications. And the interactor controls the entities. This is not a one-to-one relationship, it's a one-to-many relationship. Input and output occur through interfaces. Jakobson called these interfaces. He also called them boundary objects. There is an interface which is the input interface, that one. C++ people, these are just pure abstract classes. Java and .NET people, these are real interfaces. If you're using some other language, there's no other choice for you. Sorry. These are abstract classes. Notice that the interactor inherits from the input boundary and it uses the output boundary. Now let's walk through a scenario. Some guy does something on the web. He's filling out a form. Here's the web, this delivery mechanism here. He's filling out a form, he enters data into the form, he eventually hits the submit button. And whatever this code is, takes the data on the form, if it was on the web, I don't really know if it was, but it takes the data input by the user and it constructs a data structure called a request model. This is just a pure data structure. Nothing special about it, no methods. Just a bunch of fields, public fields. Right? Not even an object, right? Just a raw data structure. It has all of the data that was in the form. All the data needed by the interactor. It takes that request model, having built it, and passes it to the interactor through the input boundary. The interactor looks at it, says, oh, I know what this is. This is a data structure that's requesting me to do something, create an order. So the interactor grabs the data out of the request model and uses that data to operate the entities. So it fiddles with the entities, telling the entities to do their little dance. The interactor knows what the dance is. It tells the entities what to do. And then when it's done, the interactor reverses the flow, pulls data out of the entities, and constructs the output data structure called the result model. This data structure is just a raw data structure, nothing in it, bunch of fields, public fields. No trappings of the web, no hint that this is going to be displayed on a screen, just raw data. And then that result model gets passed through the output boundary back to the delivery mechanism, which will display it to the user. Can you test that interactor? It's easy to test the interactor. You create a request structure, hand it to the interactor, let it do its thing, you get the request, the response, and you look inside the response. It's easy to test it. Do you need the web server running to test the interactor? No. I can test the business rule without the web server running. Do I need anything running? Anything extra? I want you to think very carefully about it. If, in order to test a business rule, you have to have something else running, like the web server or something else, then your business rules are coupled to that something else. You have become a slave to that something else. That something else must be there. And that's bad. We don't need that something else there. We don't want that something else there. I don't want to have to fire up the framework. Anybody using Java, using Spring, or using some other web server, using Apache, and you can't run a test unless you've got Apache running, and it takes half an hour to bounce Apache? That's a bad outcome. I want to be able to run my tests like that. Just like that. I want my test to go fast. And if I structure it this way, my test will go fast. What about model view controller? How does that fit into all of this? Who knows who created model view controller? Oh yeah, who? You want me to use the legend? butcher his name. It's Trygve Rinskau, but I didn't say that right. In 1980-something, in Smalltalk, he created the model view controller pattern. Probably the very first design pattern ever named. What did he produce? Oh, by the way, I met him. It was in Oslo. It was about 3 years ago. I was giving a talk at a conference, and I was up in the speaker lounge. And I was looking for a place to plug my laptop in. I couldn't find one. And this guy hands me a power strip. And I look up, and it's Trygve Rinskau. And I took the power strip from him, and at the moment I took it, our fingers brushed. I haven't washed his hand. Trygve Rinskau in the early 80s invented model view controller. What was it? Well, simple idea. We got a model object. Model object knows business rules. We have a view object. View object knows how to display the model object somewhere. This funny arrow, that's an observer relationship. The view registers with the model, and the model tells the view if anything has changed. And then the view will display the model. Controller looks for input, usually the mouse or the keyboard, and translates input into method calls against the model. So it's a very simple idea: input, process, output. This pattern was meant to be used in the small. We would have a model view controller for a text field, a model view controller for a checkbox, a model view controller for a circle or a square. A model view controller triplet was not for a page. It was for individual components on the screen. Over time, of course, the computer industry changed what model view controller meant. And the way this happens is this. Model view controller is good. What I did is good. Therefore, what I did is model view controller. Anybody heard that argument with objects? Or anything else? If it's good, I did it. This is what model view controller has turned into in the web world. You got the web out here, and the web framework does a whole bunch of stuff. Mostly it parses incoming URLs, incoming HTTP requests, and eventually uses a bunch of routing maps and so on to call controllers which you write. Those controllers then figure out what the heck was in the request, tell a bunch of business objects to do a bunch of junk, and then the control gets handed over to the view, and the view goes back to the business object and pulls a bunch of stuff out of it and then displays it. And that's typically the way a model view controller works in the web world. This is unfortunate because these business objects begin to acquire controller-like methods and view-like methods. There's no hard boundary here that prevents a view-like method from getting into the business object or a controller-like method from getting in there. And it's difficult for software developers to keep that separation permanent without a good hard boundary. So there gets to be confusion across that boundary. Here's how we do the boundary in a clean architecture. I use this double line to show a boundary. And in this case, what we're showing is how output works. So the interactor has done its work. It's talked to all the entities, and it's gotten lots of data back from the entities. It's built a response model. That response model is going to go out through the output boundary to a presenter. Notice that the presenter is on the other side of the line, on the other side of the boundary. So this stuff over here does not know that the presenter exists. It just knows that something implements that boundary. The job of the presenter is to take that response model, which doesn't know what's going to be shown on the web, and turn it into another data structure called a view model. View model knows it's going to be displayed, but it's still not tied to the web. Everything in the view model should probably be reduced to strings. All the formatting is done. The presenter will do all that formatting. If you've got money, all of the currency symbols and the decimal points are added. If you've got dates, all the formatting of the dates have been done. All the formatting is done by the presenter as it loads this view model up with data. That data is just a bunch of strings to be displayed. If you have menus, the presenter will create the names of the menus. The presenter will create the names of the menus and pass them into the view model. If some of those menu items should be gray, the presenter will set a bunch of booleans into the view model, and the view will use those to turn things gray. If you've got a table on the web page, the presenter will create a table in the view model, and then the view can present it. What this leaves you with is this data structure that represents the screen. And to put it on the screen is trivial. This view, which I have drawn here as a ghostly image, barely there, that view simply pulls data out of the view model and puts it on the screen. What's that? What is that boundary? That boundary is the boundary between the delivery mechanism, the web, and the business rules. Look at the direction of the dependencies crossing that boundary. All dependencies point inwards. You know what that's the signature of? That's the signature of a plugin. The web has become a plugin to the application. Imagine that. You have an application, all the business rules work. You want it to be on the web, you write a little plugin. Plug into the application. It's now on the web. You want it on a thick client, you need another plugin. Plug in the thick client UI into the application. Now it's on a thick client. You want it on the console? Write another plugin. What if the UI was a plugin? Who uses a plugin? I got you. Who uses a plugin right now? In your IDE? Oh, yeah, see, everybody uses plugins. The authors of the plugin, are they safe from the authors of the IDE? Or can the authors of the IDE completely screw the authors of the plugin? They can.
If they don't stick with backward compatibility.
If they don't stay with backwards compatibility, if they don't keep the API the same, the authors of the IDE can completely screw the authors of the plugin. What can the authors of the plugin do to the authors of the IDE? Nothing. Which side of that line do you want to be on? That's this line. That line right there, that is the line. This stuff over here, the UI stuff, cannot screw the business rules. The business rules can completely screw the UI. But that's okay. We don't mind if the UI gets screwed by the business rules, because no matter what happens to the business rules, the UI is going to change. But there's nothing you can do over on the UI side to have any effect at all on the business rules, because it's a plugin. Think about that as the role of an architect. What does an architect do, really? What does a system architect do? A system architect identifies those parts of the system that must be protected and isolates it from those parts of the system that are volatile. What's more volatile than a UI? Who's got an iPhone? iPhone? Yeah? Did you get the release a few months ago where they changed everything? No. Changed everything. Changed the whole UI. All the icons look different. The way you work it changed. It's all different. Why did they do that? Well, yeah, because they can. But why? What was the motive? Was there a technical motive? Did that change to the UI make the software somehow superior? Or was it all in the head of some marketing weenie who decided one day, ooh, we should change the way everything looks because we need to keep the interest of our customers. It's a fashion statement. They changed the UI for a fashion. And all the developers went, ah. And you hope that you've got that boundary in place when that happens. Because if you don't have that boundary in place, you're going to be over here doing all kinds of interesting fashion stuff. Here's the whole picture from the interactor inwards. Here's the boundary. Solid boundary between the UI and the business rules. We've got the interactor, the two boundary objects, the request and response model. Here's the controllers and the presenters over on this side. Notice the direction of all the dependencies. Everything points towards the business rules, away from the stuff that's volatile. There's the job of an architect. Figure out how to draw that line, get all the dependencies crossing that line away from volatility. Yes?
Well, it's very nice, but what happens if you get more and more use cases? If you start putting them in more and more interactors or more boundaries to represent those use cases, you end up with a mess anyway.
Ooh, so this looks very nice. He's asking me, but what happens when you wind up with more and more interactors, and then of course you have more and more entities, and more boundary objects, and you wind up with the mess anyway? Why do I wind up with a mess? As long as I can maintain that boundary, I can keep all of this stuff over here decoupled from everything over here. And that was my goal. But let me take this a step further. Hold on. Who's got a database? Okay. Does it look like that? Is it the great God in the center of the system? Do all the applications bow to the great God database? What is a database? Database is a detail. It's an I/O channel out to a disk. What is a disk? Let me ask that differently. Anybody here got a disk in their laptop? Today? If I'd asked that a couple of years ago, I'd probably get some people who had disks in their laptop. Maybe some of you even do, and we feel very sorry for you. Most of us nowadays, however, do not have disks in our laptops. The disks have gone away to be replaced with RAM. RAM! Has anybody ever written a disk driver? You know what a disk driver looks like? You know what the physical structure of bits on a disk looks like? Right? You gotta write these funny little bits out onto tracks on the disk, on the surface of the disk. The surface of the disk is divided into sectors. Every sector is maybe 4K. You want to read a byte off the disk, you've got to read 4K and then pick your byte out of that. But before you do that, you've got to get to the sector. So you've got to wait for the disk to spin until your sector is under the read head, and then you can read that sector and get the byte out of the sector. But before you do that, you've got to decide which platter it's on. So you've got to select the head and then wait for the disk to come around so you can read the sector and get your byte out of the sector. But before you do that, you've got to make sure the seek arm is positioned over the track. So you've got to move the seek arm, select the track, wait for the disk to come around, read the sector so that you can get your byte. And that's a pain. And because that's a pain, we invented tools to make that easy. Those tools came in two varieties. Directory structure systems and databases. The whole reason for relational databases' existence is to organize data sitting on a slow, tedious, inconvenient medium and get it off that medium quickly. And the disk is going away. What would you rather have, you programmers? Would you rather have a whole bunch of offline storage that you access with SQL? Or would you just rather have lots of RAM that is persistent? You're programmers. You don't want SQL. SQL's crap. You've known it's crap for years. It's a pain. Select this, where that. Oh, I mean, it's fun to learn the syntax. It's good if you're a SQL guru, you know, you can feel pretty hot because you know how to structure all. But if you think about it, you don't want the data in that form. You want the data in a hash table. You want the data in a linked list. You want that data in a binary tree. You want that data in some convenient structure that you can access as a programmer. And look what we're getting. We're getting computers with terabytes and terabytes and terabytes of RAM. Directly addressable RAM. If I were Oracle, I'd be terrified. Because the reason for my existence is evaporating. And we can talk all we want to about relational algebras and integrity and stuff like that. The reality is, the reason that databases exist is disappearing. Now, you may like your database. That's fine. You can continue to use it if you wish. But it's a detail, and it's going away. Who's fiddled around with NoSQL databases? Isn't it odd that there's such a thing as a NoSQL database? Couch, Mongo, Datomic, all these newfangled things that are data storage techniques, but they're not SQL. What does that mean? It means we want another boundary. We want a boundary that protects us from the database. We don't want our business rules to know that a database exists. So we've got another boundary. There it is. This boundary I've drawn horizontally. The database lives below the boundary. Nothing up here knows that the database exists. Nothing up here knows the schema. Data rows do not exist up here. Has anybody seen those lovely tools that will pull rows out of the database and then hand them to the application? Say, here's a data row. I don't want the damn data row. I don't want to have that row come out and cross that boundary. What I want, when I cross that boundary, are entities. Do those entities map to database tables? No. No particular reason they have to. Oh, they might sometimes, but often they don't. For example, relationship tables just wouldn't exist. Instead, you'd probably have pointers and references in the entities. To construct an entity, you probably have to read several different rows from several different tables. So the mapping from here to here is interesting. Some people complain about DTO hell. We're not in DTO hell here. We're going to be pulling data out of a database, it's true. But when we cross that boundary, there's a significant amount of restructuring that's going to take place. Anybody using Hibernate? Unfortunately, he says. Nothing wrong with Hibernate. Good tool. Where does it belong on this diagram? Down here. Hibernate lives down here. I don't want any of these things knowing that Hibernate exists. If you've got little @ things in Java, or you got little whatever the things are in .NET, I can't remember, the little funny brackets, square brackets, I don't want any of them up here. None of this stuff up here knows. Not any of that stuff down here. This is a plugin. The database is a plugin. If the database is a plugin, can you test the business rules without it? Yeah, you just have to plug something in here. Some fake database, maybe a mock, if you know what mocks are. We could plug a mock in there. Test all the business rules without the database, without the UI. How fast would a test run if it didn't have the UI and it didn't have the database? Damn fast. Damn fast. That's how I want all testing. Fast. Boom, boom. Anybody got tests that run for minutes? Maybe.
Rails.
Rail test. What is it with Rails? Run a doggone unit test, you got to fire up the entire Rails framework, takes 30 seconds. That's stupid. Right? Why would you do that? Oh, the guys who designed Rails weren't thinking about testing. I don't know what it was. Oh, we'll just initialize Rails. No, I don't want Rails there. I want to be able to run my tests without that nonsense. So we create another boundary. Now I've made 2 boundaries so far. One for the UI, one for the database. But those are just examples. We make those boundaries for everything that is a detail. Everything that ought to be a plugin. Not just the UI and the database, but anything that ought to be a plugin. Who's using a dependency injection server? Plugin. It's a plugin. I don't want the dependency injection framework known here. Right? Take and create a boundary somewhere. Put the dependency injector on the other side of the boundary. You can inject a few things on the other side of the boundary and then somehow leak them across. And you'll have to use more mundane techniques to inject dependencies inside the business. Any framework you get, any tool you get, I want you thinking about how to make that a plugin. Because sure enough, the author of that tool is out to screw you. He doesn't know it, you don't know it, but his agenda is different from yours. And if you are a wise architect, you look at every framework out there as both an opportunity and a cost. And you protect yourself from all of them. That was a little twig for the Ruby folks. Who's used Fitness? You've seen it. So Fitness is a wiki. It's a testing framework. I'm not going to go into the specifics. What I want to do is tell you how it was implemented back in 2001. Fitness is a wiki. Everybody know what a wiki is? Who invented wikis? Ward Cunningham. Well said. Ward Cunningham, someone who should get a lot more recognition than he does. Ward Cunningham invented wikis right around 1995. He got copied by a lot of people, including me. I created Fitness, my son and I did, in about 2001, 2002. It's a testing framework based on a wiki. Now, it's written in Java. We sat down and we said, okay, it's a wiki. Where are the pages going to be stored? Well, they got to be stored in a database. What database should we use? And it was an open source project, so at the time there was really only one option, and that was MySQL. So we said, all right, we'll use MySQL. And somebody said, wait, we don't have to make that decision yet. Because a wiki has to translate markup language into HTML. And that's a big job, big business rule. Let's do that first. And so what we did is we created a wiki page class, and we implemented something called a mock wiki page, which pretended like it could be read or written. And then we wrote the code that translated markup language into HTML. We spent about 2 or 3 months doing that. At the end of that 2 or 3 months, we actually were able to translate markup language into HTML pretty well, but we could only have one page. And we said, all right, now it's time for the database, because we need multiple pages. And somebody said, well, we don't really need a database yet, because we could mock out the database by putting all of the pages in RAM and using a hash table. So we created another derivative of wiki page called in-memory page, which used a hash table to store all the pages, made it look like a database. And then we kept on developing. Feature after feature after feature after feature we developed. We did this for a year. After a year of development, we had almost all of fitness working. We could do the whole wiki thing, link from page to page. We could run tests because it was a testing framework. We had all of the important features working. We just couldn't save anything, which, by the way, was a little inconvenient. And at some point, we said, all right, we got to have persistence. Let's get the database. And Michael Feathers was there at the time, and Michael Feathers said, yeah, you need persistence, but you don't necessarily need a database. Because it's not all that hard to take a hash table and write it out to a flat file. So he came back a day later with this thing called file system page, which derived from wiki page, and took the hash table and wrote it out to a flat file. And now we had persistence. We were still developing, still testing. Our intent was still to go to MySQL. But as we kept working with it, we began to realize, as the months went by, that the flat file scheme was good enough. It was fast, it was convenient, it had a number of benefits, like we could check the flat files into source code control. We couldn't do that with a database. And in the end, we abandoned the whole database option. We deferred that decision so far that it fell off the end of the planet. And that would be the end of the story if it weren't for one other thing. About a year later, one of our customers said, we got to have it in a database. We said, why? It's a corporate mandate. All data assets. Don't you love these database guys? Yeah. Where'd the word data asset come from? You know it's some marketing guy at Oracle, right? Who came up with this term, data assets. Talk to CEOs about data assets. And they could go to a CEO and say, are you protecting your data assets? Oh, I didn't know I had data assets. Yeah, and they need to be protected, and our system protects your data assets. You know that's what happens, right? So this poor guy, everything had to be in a database. We said, well, look, here's the structure. All you need to do is derive from wiki page and implement all of the functions that we implemented here in file system page, have them stick it in a database. He came back a day later with the whole thing working in MySQL. We used to ship that as a plug-in to Fitness, but nobody used it, so we dropped it. A good architecture allows major decisions to be deferred, not made, deferred. The job of an architect is not to make decisions now. It is to set up a system such that major decisions can be delayed to the last responsible moment. Some people will say, what's the architecture of your system? And they'll respond. They'll say, architecture of my system is Tomcat, Spring, Oracle, Java. That's not an architecture. That's a bunch of tools. The architecture of the system allows you to defer most of those tools. A good architecture maximizes the number of decisions not made. And you do that by thinking about how to create a plug-in structure. What are you going to plug in to your business rules? And with that, well, you saw that one. With that, I think I'm done. Are there any questions? Yes. Is this the end, really? Yes. It is the end, really. So, question and answer. Yes.
So, have you heard idea of Prevailer and Prevalence? That's the way how to have a persistence without all the data, without all this lag. Just magically by Temat pattern. I seen it years ago and I use it quite often. So that's no database persistence.
Yeah.
Only runs but for persistence.
Yeah. So it was more of a statement than a question. It was. Do I know about Prevailer and the other tools that are like it? Has anybody ever used Prevailer? All right, it's one of those tools that came out, geez, about 10 years ago, actually, out of Brazil, if I remember correctly. And just a nice little simple tool. It gives you a bit of a persistence framework, but very, very lightweight, and no dependence at all on a SQL database, although you can put one in the back end if you want to. Nice. What else? Questions? Yep. Yes.
And if you do not follow this, then you will break, I don't know, pressing box that show.
Yep. Yep.
And when you follow this one, I guess you have to write like 20 lines to process the passage that's requested the next plugin. The problem is that it actually increases the complexity of the architecture. What's your answer?
So, I will repeat the question. The question was pretty simple. He opens it up diplomatically by saying, well, I kind of agree with you. And then he goes on to say, but sometimes when you're writing an application, you just want to open up a message box and put up something on the screen. And in order to do that with a clean architecture, you've got to write lots of code, you've got to have an interactor, and then you've got to have a presenter and a view, and transmit all this data across a boundary, and all that stuff, and it just makes things complicated. Poor baby. Yes, it would be easier from your business rules to call show message box. It would be easier. But we're not in this to make that kind of stuff easy. What we are in this for is to make something else easy. And that something else is changes to business rules and changes to UI. We want to make the big changes easy. And that means that some of the little stuff we do, the cheating stuff, that gets a little harder.
Yeah, I understand that. But it's not like one say I want to write online.
Yeah.
The problem is that sometimes I think the client says to me, I want to display message box, and I say to him, okay, I need to do that.
Yes.
And he said, no, well, this is only a message box.
Ah.
And that's the problem.
Okay, so now here's the second part of that. The second part is, no, I wasn't arguing with you at all. But, you're being a good sport, thank you. I understand that I need to do a bunch of stuff to get something up on the screen, but my customer comes me, my boss comes to me and says, wait, this is just a message box. Why are you estimating this at 2 days? Oh, well, because I've got to maintain the architecture and stuff. Well, it's just a message box. Just put the message box up. Anybody had that problem? Oh, yeah. So now let me give you a hint.
Change the box.
Change the box. Yeah. Anybody here? I don't know how things work in Poland. When you go to the doctor, do you pay the doctor?
Sometimes.
If you don't want to mate for months, you do. So you pay the doctor. Right. Now, if you don't pay the doctor and wait for months, then who pays the doctor? The government, who gets their money from? You. So you pay the doctor. All right. That means you are the boss. You are paying the doctor. You hire the doctor. Money comes out of your pocket, goes into the doctor's pocket, and he serves, or she serves you.
Yeah, right.
But the doctor tells you what to do. You go to the doctor and say, my stomach hurts. And he says, okay, give me money. And then he looks, says, well, you got an appendix that's acting up. I'm gonna have to cut it out. Cut it out? Yeah. We have to do this today. What do you mean today? I got stuff to do. I got deadlines. My boss is not going to accept me going into the hospital and having you cut me open today. Can we do it? I got an opening in September. The doctor says, no, you don't understand. I do it today, but tomorrow you're dead. Oh, come on! Be reasonable with me. And I got stuff I got to get done. I got to call my boss and talk to him about this. Maybe you should talk to my boss. Now, all right, I'll find out some way to deal with you being unreasonable about making it have to happen today. What are you going to do? Well, I'm going to put you to sleep. What? You mean I'm not going to be able to watch? I'm not going to be able to see what you're doing? No, I want you asleep. That's not acceptable. I got to watch you because you're going to cheat. You're going to take out more than the appendix. You sell it on the black market? Can't do it unless you're asleep. All right, got to be asleep. All right, well, maybe I'll get my wife in there to watch. So tell me what else you're going to do. Well, get you to sleep on the table. And I'm going to cut you open right here. You're going to what? I'm going to cut you open right here. Come on, it's right in the middle of my stomach. Can't you, like, do it, like, there? You go to the doctor tells you what's going to happen. If you hire a lawyer because you've committed a crime or because someone is suing you, you pay the lawyer. The lawyer tells you what to do. This is the mark of a professional. Professionals are hired to tell their employers what to do. Employers may not like it. They may not like what they hear. Doesn't matter. You were hired to tell your employer what to do because you are the ones who know. They don't. You have the knowledge. You are the professionals. They don't. Now, the employer comes to you and says, I used to be a programmer. I know what it takes to put up a message box. You're estimating 2 days for this. I know it's not 2 days. It's 30 seconds. It's just show message. And you look at the employer and say, you're right, that is how it was done when you were a programmer and you screwed everything up. We don't do things like that anymore. Nowadays, we care about our customers. We want them to be able to make changes, and we need to protect the system from sloppy work like that. Now, the reality is, if you're going to put up a message box, and if you're going to do that a lot, then you're going to build that little communication pathway once and use it all over the place. So in the end, it is going to be a show message, real simple. It's just that first time. That first time when you think, oh man, I could just say message.show, and I got to build the communication path. But you build it, and then you use it easily from there. Anybody else? Oh, in the back.
How are these concepts you have just shown to us different from providing a service and repository layer, which are very common applications?
How are these things that I've just shown you different from presenting a service and repository layer? They're not. This is a service and repository layer. It's just that I've generalized it somewhat to show that you can create plugins like a UI and a database and another framework out of just about anything in order to protect the business rules from volatile stuff around the outside. A service-oriented architecture, God help you if you've bought the tools. But a service-oriented architecture in its pristine form is a very lovely thing. Now, if you buy the goofy tools from the vendors and you buy into the goofy arguments, you'll spend a fortune and make a mess. But if you follow the simple architectural rules, you wind up with something very nice. Never underestimate the power of a vendor to create marketing messages that your employers will buy. Stupid. Anybody else?
Starting to talk the picture of a groups folder of a Ruby application. You said that it's not written, you cannot recognize the intent of the application. How does that implement the same application with this architecture?
Yeah, so the question was, we started with the image of a Ruby program and the folder structure of that Ruby on Rails program, and I said, why can't I see the application here? Why can't I see the intent? And his question very reasonably was, what would it look like now? Well, what it would look like would be a folder that contained interactors. And if I opened up that folder with interactors, I would see every business rule name in there. Every business rule, every use case would be mentioned. I'd have another folder called entities, and I would see inside that folder every entity that took part of those business rules. I would see another folder called boundaries. I would see a folder named input requests, or request models and response models. I would see very quickly the intent of that system. I could see all of its communications pathways in those request and response models. I could see all the interactions in the interactors. I could see all the little nouns in the system with the entities. So the architecture ought to become very apparent. The intent of the system should become very apparent. Anybody else? Yeah?
You started this talk saying, like, in the middle of the 90s, there were people who already had this concept in mind. And 20 years later, we are still, talking about this topic and something new for most of us.
Yes.
What happened?
Yeah, so if you remember, everybody getting this? The name of this talk was Architecture the Lost Years. Why was it called the Lost Years? You know what drove this out of our heads? Jakobson wrote that book in '92. We were just starting to internalize it when the web changed everything. And the web blew it out of our heads. The whole notion that, oh my God, there's an internet, and we're going to have web pages, and it just changed everything. And it blew the whole structure out of our head. Was anybody here writing code in 2001? You remember what happened? The whole economic structure came crashing down. We had the dot-com bubble that broke. And there were people out there holding signs, "We'll code for food." We went through 2 or 3 years where it was very difficult to get a job as a programmer, even in the United States. The whole IT community was badly depressed. And during that period, we weren't thinking about architecture. All we were thinking of is somebody's going to pay me to write a line of code. After a while, we kind of recovered. Get back into 2005, 2006, 2007. We sort of recover, we get our feet back under us. Now the industry's going great. Because if you're a programmer, you got a job. That's probably true here too, isn't it?
Yes.
If you're a programmer, you got a job. Is there another bubble coming? Remember I said that if you're a Ruby programmer in the United States, you can write a number on a piece of paper and find somebody to pay you that number? There's a social networking bubble out there. I don't know when that's going to break, and I don't know how, or even if it's going to break, and I don't know how disastrous it will be if it breaks. But it smells like a bubble to me, so I would be a little careful with that. What's that? With Ruby? I think Ruby's a great language. Everybody should learn it just because it's a great language. And by the way, if you're a programmer, you should be learning a new language every year anyway. The worst thing you can possibly do is say to yourself, I'm a C++ program and I'll die a C++. That's how you die soon. You want to learn new languages. Ruby's a great language to learn. It's a completely different way of working if you've never done it before. Give you a lot of very powerful insights into the way code can be structured differently than you're used to. So I wouldn't say not to learn Ruby. I would be careful of the social networking bubble. Lots of people want to get into this. There's a lot of money getting floated around. I don't know if it's going to last. We'll see. Just something to be careful of. Anybody else? Let's do a couple more. Yeah.
Let's say that I have a fairly simple application, which has, let's say, around 90% of it is a single CRUD kind of application.
CRUD, yeah.
How would you implement it? Would you rather go in direction to implement everything using all the principles of the clean architecture fully fledged, or would you try to make some shortcuts for the simple CRUD? Like, let's say you have a very simple entity which actually doesn't have any business rules, just data which is stored, right? So you can put hibernate annotations there and put it back to the web. Or would you maybe develop the interesting part of the application using the clean architecture and the other, I don't know, auto-generator or something?
All right, so interesting question, and I'll paraphrase it. If I've got a really simple application to write, a CRUD application, create, read, update, delete, would I use the full-fledged clean architecture with all of its bells and whistles, or would I find some shortcuts? And the answer is I'm always looking for shortcuts. No matter what the application is, I'm looking for shortcuts, but not evil shortcuts. Right? Shortcuts to get something simple done fast. So, for example, I talked about that request model that came out of the delivery into the interactor. That doesn't have to be a data structure. That can be an argument list. I can just call a function with 3 arguments. Why would I make a data structure if I can call a function with 3 arguments? So I would do that kind of very simple shortcut. Would I thwart the direction of those dependencies? No. The direction of the dependencies I will keep there. I want the plugin structure. Even if it's a simple CRUD app, I want the plugin structure. And here's the thing about that, it's not that hard. You got OO languages, they make it all trivial. It's not that hard to make all those dependencies go the right direction. It saves you a ton of time. You get tests written much faster that way. Who's doing test-driven development? Look at that, a lot of people. DDD is dead, yeah. We all read that nonsense, didn't we? There's no way to write your test faster than to decouple this way. So my goal would be to stick stick to the principles of the clean architecture, finding ways to make shortcuts that don't violate those principles. One more question. Here. So the question is a very, very good question. He says he sees a lot of similarity with the hexagonal architecture, sometimes known as ports and adapters. Is that similarity real or is it an illusion? He didn't say it that way, I did. No, that's exactly what we're talking about here. It's the same architecture. You will find that there are a number of authors out there who have written this over and over again. The ports and adapters architecture, the hexagonal architecture, the DCI architecture, clean architecture, they're all instances of the same idea. And that idea is real simple. Separate